Okay, so this is our first video about light specifically. Now light is a wave, so this fits very much with our current unit, our current focus of study. Light is a wave. However, it is, the way we treat it is a little bit different from the way we treat water waves or waves in ropes or waves in springs or slinkies or whatever you would like to think about as being a wave. We treat light a little bit differently than that, but it is a wave and it can be viewed in many of the same ways. It has all of the same properties that any other wave has, including reflection, refraction, and diffraction, which we're going to look at in detail with light, at least reflection and refraction. We won't look so much at diffraction, but anyway, that's where we're going. What we have here is a couple of pictures to illustrate that. We're going to look at this picture in a lot more detail later in this video, but it's illustrating the principle of reflection. This is just a picture of the sun shining past a cloud, and you can see this, what we call a sunbeam. The reason you can see it is because it's reflecting off of dust in the atmosphere. Anyway, the only light you can see is light that actually enters your eye. If the light does not enter your eye, obviously you can't see it. So there is light all throughout, all over this place. There's light going through here, but it's not hitting dust particles quite the right way, so you don't see it. You do see this beam, just because of the way that it hits things exactly right and bounces off of them, and the light then enters your eye. Totally crazy. Anyways, so these illustrate a couple of principles which we're going to get into in more detail right now. Okay, so light, first principle, these are foundational principles about light. Light is a wave, which we already said. It can be drawn as having wavefronts, just like we draw for water waves. It can be. We almost never draw them that way, but it could be drawn that way. And just to show you, kind of like this, the way we draw water waves as having wavefronts, like that, you know, where this is a crest and this is a trough, and that's a crest and that's a trough. We could draw light that way also, if we feel like it. And then most of the time we don't feel like it, so we don't draw it that way. But we could. Alright? Like any other wave. So this is number 2, principle number 2, big idea number 2. Like any other wave, light travels in straight lines only. It cannot turn without hitting an object or diffracting around a corner or through a gap, like water waves do, alright? Light travels in straight lines. Straight lines. I'm not drawing a straight line there, but the point is, light travels only in straight lines. It cannot just suddenly in midair turn. It has to hit something in order to turn. Alright? So number 3, for simplicity's sake, we treat light as though it were a ray. We call it a light ray. Almost like a vector. It's a line with an arrowhead at the end. So it might look something like that, right there. Okay? So that's the way we're typically going to draw light, is something like this. A ray with an arrow at the end. Alright, moving on. Okay, so one of the principles of light is reflection. Sorry, one of the features, one of the things that light can do, one of its properties, is that it can reflect. So light can bounce off of things, and in fact light reflects off of things all the time. When it's not actually a mirrored sort of a surface, we don't really call it reflection in common speaking, but it is. Any light that bounces off of any surface, regardless of whether it's shiny or whether we can see an image in that surface, any light that bounces off of a surface is reflection. Okay? And all of it follows this rule. Now, if the surface is really bumpy and uneven, then what you get is called a diffuse reflection. Just wrote it in there. Diffuse reflection. So it's diffused. It's spread out. It's not all even. So you don't actually see an image in diffuse when you get diffuse reflection. Diffuse reflection. You don't see an image in the surface, but you do see still the light because you can see the surface. So anytime you can see something, that means that light has bounced off of that thing and entered your eye. Crazy. All right. So one of the things about reflection is this. When you have the light that strikes the surface, this part, because this is the light source over here, so this is called the ray of incidence, or the incident ray. angle of incidence, the incident ray, and then this ray is the one that bounced off, so that's called the reflected ray. Incident ray and reflected ray. So let's zoom in here, and I'll write those down for you. Okay, so the incident ray is over here, bam, and the reflected ray is over there. So they're written in so that you can see them. One thing you might notice, since this is all set up very nicely on a protractor so you can see it, the angle of incidence is exactly equal to the angle of reflection. You see they are both right here at this mark on the protractor. Now on the next slide we're going to look at this in a lot more detail, but just notice here, the angle here is equal to the angle there. So the angle of incidence is equal to the angle of reflection, and that is called the law of reflection. All right, angle I is equal to angle R. Okay, now it's important to notice when we measure these angles, and we're going to see this in more detail again in a minute. When we measure these angles, we do not measure from this surface. No. We do not measure from the surface that it reflects off of. We measure from the normal line, which is 90 degrees to the surface. A normal line is a line that is drawn 90 degrees. 90 degrees to some other line. It's perpendicular. Alright, so it's called the normal line. It doesn't mean that it's like common or usual or something like that. It's just a specific physics term. It's normal. It means perpendicular to the surface. Okay, so looking in more detail at the law of reflection and the normal line. So if we zoom in here, here's the normal line. It's drawn at 90 degrees from the reflective surface, starting where the light ray strikes the surface. That's kind of important also. You have to draw your normal line at the point where the reflection occurs, right there. Okay? Now if we do that and we look at our protractor, we see that we have here, this is a 50-degree angle, and here, that's a 40-degree angle. So then the question is the angle of incidence. Is it 50 degrees or is the angle of incidence 40 degrees? Which one is it? We could say that the angle of incidence is 50 degrees, or we might say that it's 40 degrees, but you can tell, right, which one's the correct way. There is a correct way and there's a wrong way. There's an incorrect way and there's a correct way. The correct way is to say that it is 50 degrees, not 40 degrees. Okay, so we measure the angle from the normal line, not from the plane of the reflective surface. All right, we do not measure from the surface, we measure from the normal line. Okay? That's what I've got for you here as this introduction to light, and I hope that helps you. We'll work more with this in class, and I will see you next time.